scale circulation, because even though you look at paleoclimate, they were measuring all the corals also up to now. Can you distinguish in your coral measurements El Niño years, La Niña years, normal years, looking at basically the present measurements in the corals to see how they reflect the larger scale circulation? I had a wonderful conversation, I don't think she's here now. She's a student, oh yes, yesterday, and she's looking at corals which are very near the surface in the Makassar Strait. And she finds a fantastic story of the correlation through the Makassar through flow, which is the Sibutu Strait coming down Makassar, or the other one, which is the South China Sea through flow coming from Luzon. So I was wondering if you can correlate your measurements. They are not surface, her corals come to the surface, but if you can really make a similar story, distinguish between El Niño, La Niña years and normal years.
Okay, I'm not going to be able to answer for the tuna coral, although Intan probably could answer the question if she were here. But it depends very much on the sighting of the coral and what you're going to see. In some areas, if you have a strong sea surface temperature signal, you'll see that. But in other areas, you'll see it in the rainfall, and then it'll come out in the salinity signal. So it very much depends on the sighting of the coral relative to the ENSO process. The tuna is not really in an area which is going to be directly showing warming due to ENSO or its salinity due to rainfall from ENSO. So I'm not sure that it would show that signal. But again,
What is your coral? What are your corals? The location of your coral site?
The southern Makassar Strait. So just east of the Java Sea, that southern portion.
It is inside Makassar Strait, on the left side in shallow water.
Yeah,
It is in Makassar on the left side in shallow water.
yeah, so you have the seasonal South China Sea influence coming from this really shallow Java Sea, and then you have the Indonesian through flow going through the Makassar Strait.
No, I understand. Your location is totally different. I understand. Because again, yesterday we were talking and we are thinking with June to modify our grid in such a way as to resolve much better the little strait like Sibuto, which come from Luzon and go down to Makassar.
Actually, I have a question for Ed. So I remember in your talk, the record for SST record from 1920. Is the location actually is between my region B and region C, somewhere and south of the Vietnam, right? So you link that to the ITF, so stronger ITF and the weaker ITF. So according to my understanding, ITF doesn't go into the South China Sea, so that should be the South China Sea true flow and not the Indonesia true flow. Is that correct?
but the plot showed for those few years where they had the data, there was a correlation between the density in the South China Sea and the strength of Indonesian through flow, even though at Natuna, it's not the Indonesian through flow that you're seeing. So now whether we can come up with a mechanism that would account for that correlation or not depends on whether you'd want to believe it in the longer term.
Okay, so we cleared that. We have more questions from the audience. Oh, Leslie.
I can check.
Okay.
You were cut off, ran out of time when you were talking about chemical sensors, and I thought you were saying something that the geometry, the shape of them mattered. For chemical sensors, is it purely the chemistry, or are you trying to? Where's the biomimicry involved in the chemical sensing? I guess is the question.
Yeah, the biomimicry of this particular sensor, because there were some other sensors which we're talking about, was trying to emulate the ability of sharks to detect very small parts of blood, for example, in the water. And it's a matter of concentrating a lot of fluid passing through a relatively small area. So the lamella of the shark and the equivalent biomimetic, we had all these little pillars on which, through microfluidics, basically it's forcing a lot of flow through this, and that makes it possible to detect very small traces of the material. So that was the biomimetic in this particular part. It was not on the function of the sensor itself, but in terms of the microfluidics.
Hi, I have a question for Michael as well. So it's always so fascinating to hear you talk with all these great soft robots and biomimetic sensors. And I was wondering, with all this technology that you've developed, could you comment on kind of the application space for that and how that's evolved over the time in Sensam or beyond?
Sure, the easiest application is in terms of the sensors, because we used these sensors in the field. So we used the whisker sensors, we used the flow detecting both velocity and pressure. So for example, we put it in small AUV, so if there is a side current, the AUV can detect there is a side current, and instead of trying to fight the current and spend its battery, it's doing what is the equivalent of tacking in a sailboat. And you can save a lot of energy by doing that, so you don't get all the cross-flow drag. So the sensors are the easiest to apply. In terms of the robotics, of the biomimetic robotics, it's still in the development, but you get principles to apply. For example, the use of fins by vehicles. It's something that actually now we are implementing, because the fins are controllable. So if you watch a tuna, or better a sailfish, they have these huge fins which are they employ. This changed what's called the aerodynamic center, which is a very important property of streamlined bodies, because those determine maneuverability. And if you open the fins and close them, what you do essentially, you instantaneously impose an unstable body which turns a lot faster, and then you stabilize it. So this morphing of wings is the first fruit of all this effort, which will allow vehicles to turn very quickly. So it's coming along, but it's still, we need materials, flexible materials, which will be able to implement this flexibility of the fish. So we're going closer to that. But the concepts, how they get applied, they may not look at all like fish do or anything. You learn and you do different things. For example, the octopus, we are not going to make vehicles which swell and expel, but there are other things that we can do to increase temporarily one part of the wing, for example, and then quickly retract it.
Thank you, Michael. I think there's a question in the back.
Okay, Ed and Junvei, a question for the two of you. I'm wondering about other extreme meteorological events, such as years that maybe have considerably more typhoon activity. Or you both talked about El Nino and La Nina, but the other dynamical conditions that set off the large-scale changes in the interannual variability of the monsoons or of the hurricanes through the areas. Have either of you seen any of these types of signals in the two different approaches that you take?
I can be quick. I haven't searched for that, so the answer is I don't know.
This is a climate model, so the time scale is up to the seasonal. So we didn't look at the weather scale. No.
The question goes for Gonzalo. Gonzalo, you have conducted a lot of field work in the region, and that represents a big effort, a big coordination, and a lot of collaborations with the people in the region. I'm wondering if you could elaborate a little bit more on your experience.
Well, that's an interesting question. Yes, I mean, pretty much things started slow. I mean, initially I had to get all the permits and all the things to get things up and running here in Singapore. And then I basically lucked out with Moritz and Asani and Yanni and then Jenny, and then a lot of people ended up. I mean, Malaysia in general terms is a small ecosystem. So you know one person and everybody knows everybody else. And then I basically lucked out with a couple of friends who opened up to a lot of other friends, and then soon enough we were all happy about sharing boats and doing things together. Because, I mean, the truth of the matter, I mean, the naked truth is that Malaysia doesn't have a lot of money, right? And Singapore does. So there's a lot of things that we can do that they cannot, and there's a lot of things that they can do that we cannot. So we help together, and in a team effort, it gets done. It took some time at the beginning, but after we made friends, we were just super happy to work together. Yeah. Thanks.
This is a question, I'm going back with my memory. In one of your past presentations, I remember you talking about mimicking the gills of a fish. And the gills of a fish and the mechanism with which the fish breathes, so to speak. Am I wrong? Because I remember you showing the gills of a fish and trying to mimic the behavior.
No, I haven't talked about that.
Not now. Oh well, maybe there was your socia.
It could very well be one of the students that was talking about that. Yes.
Okay, well, obviously, I'm talking about my memory is failing. Never mind. Sorry about that.
Sorry, I would like to ask Gonzalo a question. Hello. Yes. I was quite excited to see your zinc data. It's the first time I've seen it, and then the Rajang is extremely exciting for me, for our work. I was wondering if it's due to the amount of organic matter that's coming out of the river, or is it an anthropogenic source, or do you have any input on that? Because we have all this organic matter coming out. We think it's the largest source of organic matter to the South China Sea ever measured so far. Mm-hmm. So is it due to just the sheer amount, or is it due to the deforestation, oil palm plantations, and so on? So,
well, you know, the Rajang and all those rivers in Borneo are basically like an open question, right? I mean, we can look up some things and on Google Maps, and then we go and we find something that is completely different, right? One. And then two, as you start to go up and down through the salinity gradient, there were a couple of places that it wasn't just simply organic matter from the river itself, you know, sort of diluting down, or at some point precipitating out, and just a little portion, so surviving the salinity gradient and going out. There were a couple of things that were a little bit confusing. So I am really looking forward to getting my paws into more of those samples later, to basically to answer these questions. Yeah.
Thank you.
Okay, so I think this is a good time to thank the speakers again. And it has been a very interesting mixture of topics, which is kind of reflecting the interdisciplinary character of environmental science. So let's continue the discussion over a cocktail, and thank the speakers. Thank you very much.